Okay, hello everyone. This is day 2. As you can see, it's 10:08. It's a little late. I came home late from work. I had some business to take care of after work. Got to go see some interns and whatnot. And then I got home late, and I totally forgot to record a video. So I'm here now. I'm gonna try to see if I can make this quick, because I have to be up at 5:40 in the morning. It's kind of late, and I didn't get much sleep last night, so we shall get this done ASAP. So last time we were working with arrays and hashing, and I was thinking about hitting up the 2-pointers. Let's see, I think I'll do these 3 easies, just because they're pretty quick, and I'm pretty tired. So yeah. Let's do some LeetCode. Pull it up. Okay. So let's read the project or the problem statement. So given an array of integer nums and an integer target, return the indices of the 2 numbers such that they add up to the target. You may assume that each of the input would have exactly one solution. You may not use the same one twice. Okay. I have done twosum before, but not going to lie, I kind of forgot how to do twosum, which is so funny because it's a very easy problem, but it's a problem I haven't done in a year. So it's been a little bit of time since I have any recollection of how to work this problem out. So let's think about it. It's a little bit different than the hashing problems from yesterday. Those are pretty easy. Just kind of, do a dictionary and then call it a day. This one actually, I think, requires a little bit more. We'll see. So you have 2, 7, 11, 15, and target equals 9. And then output is 0 and 1. Okay. So I'm thinking that we're going to be doing a greedy solution. Okay, yeah, exactly one solution. Okay, so I'm thinking we're going to do something greedy. Okay, so here's how I'm going to kind of pick this apart. Let's take a screenshot of this, and what would this is the first ever LeetCode. Okay, swag. twosum. This is where everything started going south. Am I like hella zoomed in? Hella zoomed in. Yeah, that's super zoomed in. Let's do like 20, and let's definitely fix that box. Okay. Okay, so put something like that. I'll come back to that. I'll do put. I think it was like 58 last time. 58. Okay. twosum. Everybody loves it. So we want to take a double pointer greedy approach. Yeah. Fix that. So what this means is we will start with a pointer at the beginning and another at the end. If the okay. Specific. Is that, am I spelling it right? Whoops. That does not look right, but I'm tripping. the array has to be sorted for this to greedily work. So if you don't know what greedy means, greedy just means you look at the current situation you're in right now. So there could be multiple steps it takes for you to get to the finish line, but you're looking at the one right now at this moment in time, and you're picking the best version. Now, greedy basically, as an algorithm, means anytime you do that, you will always reach the best goal. That is when greedy works. Now, greedy doesn't always work, obviously, because there's going to be multiple times where taking the best path at this current moment will harm you later. For instance, if you were at a fork in a road, and one road is like 1 mile and the other one's 100 miles, right? And then if you're like, oh, I'm going to take the 1 mile road, right, to get to my destination. But then after the 1 mile road, you have to go take a 1,000-mile road. Okay, that was obviously not optimal. But whenever you chose the greedy pathway, you went down the wrong path. In this instance, we know that greedy should work because the array is sorted, or has to be sorted. So what is greedy about this? So here's the greedy part. I'm going to put this. So greedy part. We combine the sum of the 2 pointers. If the sum is greater than the target, then we move the end pointer left. If the sum is less than the target, then we move the beginning pointer right, because moving it right means the sum will get bigger, and then moving the end pointer left means the sum will get smaller. So we're basically kind of like course correcting that. If the combined values is equal to target, then return the indexes. And then if the right index is to the left, sorry, if the end index is to the left of the beginning index, then there is no solution. Okay. So that's pretty much how that works. Time complexity, this is O(n), right? Because you're just kind of linearly passing through the array. So, not that, right? Or O(n) or O? It's not log(n), right? I don't. Can you come up with an algorithm that's less than O(n) squared time complexity? Yeah, this is not n squared. What? N squared? For 2 sum. Interesting. Okay, so how would I program this? So I would say I'm going to make a variable left pointer. I'm going to make this equal to 0. So this is the 0th index. I'm going to say right pointer. I'm going to make this equal to what is it? Length nums? Is that how Python does it? Yeah, I think it's length nums. And then -1, because indexing. So if the list is size 10, we want index 9 for the last item. Okay. And then I'm going to write a while loop. So while. Okay. Interesting. While. So this says there has to be at least a solution. Sure, but I'm silly, so. Oh, and also because it can't be the same, then we'll do something like this. So basically, if the nums of the left pointer plus the nums of the right pointer yeah, so if those combined, oops, I am not coding in the right way. Let's do that. Yeah, if those combine is greater than the target, then we need to decrease the size a little bit by moving the right pointer a little bit left, right? We're making it smaller. So I'm going to say right pointer minus equals 1. Elif, we're just going to go ahead and... Actually, we're just going to copy all of this. So yeah, elif, if is less than a target, then we're going to do left pointer. And then else, which means if it's not greater or less, means it is equal to. And we're just going to return. Hey, okay, man, chill out. Sorry, my cat's a little angry. We're just going to return the list. So I'm going to do... buddy, it's okay, man, relax. Hey, stop. We're going to say answer equals left pointer, right pointer, and then we're just going to return answer. Hey, dude, chill out. What's going on, man? Relax. And once you do that, that'll give you the answer. And then I'm just going to do return none. Which shouldn't technically ever be called based off of the implication of this problem. Oop, wrong answer. Okay, so I return nothing, or I return null, right? Which is apparently, yeah, it's 2 and 4. Interesting. So I'm not reaching 2 and 4. Is what I'm getting at here. Oh, it's not sorted. Okay, so this is not gonna run in log O of min. It has to be sorted. I made the assumption that it was already sorted. Not that I would have to sort it. Stop, man. Chill out. What is the Python sort function? I forgot what it's called. Okay, it's just dot sort. Wow, super nice. Nums dot sort. There you go. Let's try that. Not tripping. Oh no. Oh. Unfortunate. I have to keep the same index. Oh, you're trolling. Okay. That's annoying. Yeah, that's gonna suck. So like, this makes it a little bit more tricky. I'm trying to think. I think there's a... okay, so this requires some kind of finagling of the situation to kind of like get it to work. I'm going to devise a different idea. Because I don't want to kind of count that. Alright, so... annoying. Because it's... because of the ordering. Should have read the problem better. I automatically thought it was sorted. Okay, so now I'm thinking I'm gonna do... I have an idea. So here's my second idea. My second idea is we're gonna actually go back to using dictionaries, which is kind of silly because we're going right back to hashing. And so what I'm gonna do is I'm gonna store the dictionary value of so like, here you go. It's gonna be, you know, the key value pair. So it's gonna be the dictionary of the actual Well, wait. No. Hold up. Sorry. You gotta take a think about that. So I was thinking I'm gonna use the dictionary of the value. So like, and then that would give you the index, which is probable. Okay, so now I can see where the n squared is coming from, which is kind of annoying. This might work. Oh man, the easiest like LeetCode problem. I'm literally sitting here having a conundrum about it. Okay, I'm gonna make a dictionary, so I'm gonna just call it dictionary. Man, dictionary. All right, and this is just gonna be me testing something out. For index, or sorry, for element in element in nums, or right, is it enumerate? Is it enum? No, it's definitely enumerate. I forgot which order it is. Is it that order? We're just gonna do run that real quick, just to if I remember the order properly. Okay, so this is index, and this is element. Now that works. Kill. Okay. So I'm gonna say, hey, basically if an element or no, we're gonna do this. If target minus element, target minus element is in dictionary. So basically, if what we're looking for is a dictionary it's gonna have the element, it's gonna store the index. So if you basically like I store this for later use, like let's say I store this 2 for later use, because like how I run this 2 and I don't use it, so I store it. Then later on, what I'm going to do is I'm going to look and say, hey, if target, which is 9, minus the current element, which is 7, is inside the dictionary, which it was, it's 2, then that means that there's a pair, which then means I can then go grab the index and then return it. So here I would do so basically if that's the case, then just return let's see, return a dictionary of this value. This kind of looks ugly, but we do what we got to do. And then index. Okay. And then else, we're just gonna say dictionary of element. Hey man, relax. Stop. Say dictionary of element is equal to index, and then return null. Okay, so I'm not entirely too confident this will work, but we'll see. Oh, there you go. That's the test cases. Submit it. This is incorrect. Just delete that. And it works. And it's fast. Swag. Okay. So I guess I'll explain it now that after I've done it. Or I guess I kind of did explain it a little bit. But well, this is an O-of-N approach using a dictionary or a hash map. And so what I'm basically looking for is kind of a pairing between them. So I will store all failed values, or values that don't cause return. So any sort of value that like, hey, if the target minus the current value, if it doesn't already have a pair that's in the dictionary, then let's store this in the dictionary. Maybe we'll use it for later. And because this problem statement is exactly one solution, we definitely will use it later. That's why we can use dictionaries. But for a problem more complex, we would have to use kind of like a more greedy two-pointer approach. I am curious to actually kind of watch this video, because I definitely did this the incorrect way. So let's see how he did it.
Hey everyone,
Oh, valid palindrome. Oh, no, it is hashing. What? My brain was thinking we were doing two-pointer. Man, I need to pay more attention. Okay, now we're going to be doing two-pointers. LOL, what the heck. I'm just gonna, yeah, just gonna leave that blank, because, honestly, why not? Valid palindrome. Okay, so, valid palindrome. This is problem 125. So, we're gonna do 125 dot valid palindrome. And actually, I'm going to copy that, and I'm going to do a box. My cat is tweaking right now. I was gone for a week, and my cat is absolutely tweaking. Here, buddy. Okay. So a phrase is a palindrome if, after converting all uppercase letters into lowercase letters and removing all non-alpha numeric characters, it reads the same forward and backwards. Okay, so I'm gonna have to do a feature of cleaning it and then reading it. This is fairly simple. So let's do the cleaning part. So, cleaning part is going to basically, we're getting rid of all the uppercase and lowercase, and removing all non-alpha numeric characters. So, that is how I would kind of do that. So how I'm going to clean it is, if it's capitalized, lowercase it, space, delete it, right? Commas, colons, delete it. How to lowercase a character in Python. Does that allow char.lower? Oh, so nice. So nice. I love Python. I was wondering if I was going to have to build a dictionary to do that for a second. Thank the Lord. So I'm going to do a cleaning thing. So this is going to be O then for the cleaning. So basically for... Oof. Yeah? Yeah? I think this works. Let's hold up. Let me just test this out. So my idea is I'm just going to loop through and just clean it up, but it might cause an issue. Can I plus equals in strings with the in Python, or is it like you have to remake the string? I don't think you can do inline string editing. I don't know. I think that's a Python strings are non-mutable. Immutable is the proper word for that. Yeah, pretty sure I can't mutate a string. So I'm gonna have to make a new string. So I'm gonna say clean string equals empty string. Okay, I'm gonna do instead. Actually, no, I can do this. For index in S, this is just gonna make it so much cleaner for me. I'm gonna say clean string if index dot, what is it, is alpha. Python is alpha. What's the, alright, dope, love it. Is alpha. Oh man, I need to stop with these parentheses. I'm trolling right now. So if it is an alphabet character, then I'm going to say that clean string plus equals clean string plus index dot, what is it, was it 2 lower? Just lower. Index dot lower. Okay, so this cleans out the string, and I'm gonna actually just test it real quick. Print clean string. Ah! What is going on? What? Oh, plus equals. Oh my goodness. Okay, so plus equals does work. Wow. I just did some factorial. Okay, a man, a plan. Alright, dope. Sick. Okay, so now you have the clean string. So this kind of cleans it out, gets it all pretty. Looks great. Looks nice. And the next step would be to actually do 2 pointers. So basically we can just work from the outside and then work inward, and then kind of see if it works out how we planned it to. So, sorry, a little tired. So I'm gonna have a pointer similar to what we were trying to do with TwoSum, but then we messed up, right? The original idea with TwoSum is actually what we're gonna do here. I'm gonna have a pointer to the left, and I'm gonna have a pointer to the right. Okay, and basically, if they're the same, cool, move it. Right, so I move left and I move right inwards. We're not gonna move one at a time, but they're both moving at the same time. And each time it moves, we're gonna check it. Is it the same? Yes. Is it the same? Yes. And then we will stop it once the left side is greater than or equal to the right side. Sorry, the left index is greater than or equal to the right index. Because at that point, we know we've hit the threshold. Right? And the reason why we say greater than or equal to, so if it's greater than the right side, then we've crisscrossed, and now we've already checked that. If it's equal to, that means we're looking at the exact same index on both sides, and of course the exact same index is going to be equal to itself. So that's pointless to even check. So this will create a O(n) solution. So we have O(n) here, and then another O(n) for what we're about to do. So now we're going to actually do the is palindrome part. So I'm going to say left pointer is equals to 0. Right pointer is equals to length of s minus 1. And let me fix this before I get syntax errors. Okay. And then this is where I do my while loop. So I'll say while left pointer is less. I just can say less than, right? Then a right pointer, and then we're good to go. If the string's left side is equal to the string's right side, then we're good. But if it's not, so the only time we need to check is if it's not, then we're not good. So if they're not equal, can't be a palindrome. And then if you kind of go through this whole thing, if you go through the whole loop, and you check every single thing, every single left, every single right at the same time, you keep going through, and you get to the very end, and you never return false, it must be a palindrome. So yeah, after you check this, then you can increment it. So I can say left pointer plus equals 1, right pointer plus equals 1. Okay. Why am I failing that? Where am I failing at? Print. Oh, silly guy. I literally made a clean string and I'm not even using it. I'm so silly. Okay. Did I get rid of that issue? Oh, wait. Nope. Didn't get rid of it because I'm still checking the length. Man, what am I doing? Okay, let me wait 5 seconds. That's like immediately click again. Index out of range? No, I get it from earlier, but I rewrote it. Did we not refresh that? Out of range. Am I tripping? Hold up. Not gonna lie, a little bit confused. I'm gonna make a cautionary thing. I'm gonna say if right. No, wait. What am I airing out on? What is my runtime here? Index, string index out of range. Okay, but what part? So now I'm kind of getting a little like confused as what are we doing here? Because what is that range? Is it right pointer starting off in a not so great area? Like, I mean, output limit exceeded. What are we talking about? Oh my days! What am I doing? How did that happen? How did I not see that? All right. Yeah, I don't know how that happened. I'm gonna be completely honest. Oh, man. All right. Sorry about that. I'm not paying attention. It's a little bit too late. I'm a little too sleepy. Again, out of range. Why? I'm like, what? What are we out of range from, dude? Hello? Oh, man. Tired. Alright, okay, so that's the issue. Right pointer is -1 already. This... Okay. Oh, man. I gotta get my eyes checked. It's getting bad out here. It is getting bad out here. Thank you. Okay. That was embarrassing. Oh well. It's gonna fail again. Okay. Alright, so I was accidentally checking if left is greater than right, which makes no sense. So now it should work. There were so many errors there, so many really silly errors too, which is kind of funny. But that should work now. Let me explain it after I run this solution. Wrong answer. Okay. So it cannot be a palindrome if there's only one. So I'll do like an edge case. If length of clean, whoops. If length of clean string is equal to 1. Return false. I guess that makes sense. Okay, do you wait. Do you want me to a phrase of algorithm converting all uppercase letters in lowercase, removing all non-alpha numeric. Oh man, I'm getting rage baited right now. Alpha numeric. Yeah. Yeah, that'll do it. Alpha num. Okay, so let me clean this the proper way. So alpha numeric. Okay, sorry. I wasn't cleaning it properly that time. Apologies. That took way longer than it needed to. So let's actually read the description. Alpha numeric characters. So basically what I'm having right now is I'm starting off a new string called, and we're going to make that a cleaning string. We're just going to clean out all the characters we don't need. So we do want numbers. So we want characters, alpha characters, and numerical characters. And we want everything to be lowercase as well, nothing else. So we're going to get rid of spaces, commas, parentheses, everything, etc. So what is happening is it's going to go basically through the string that was given, and then, hey, if the current index we're looking at is actually a alpha or a numerical character, and hey, let's add it to our clean string. Make sure that we do a lowercase of that, right? It'll kind of ignore this to lower if it's a number, as you saw. So we don't have to worry about that. So after running this loop, it will basically go through every single character, clean out what we don't need, fix the alpha casing or upper casing, and then it'll add it to our thing. So now we have clean string updated and ready to go. Now we have a left pointer is equal to 0. So that's our starting side, that's going to be our left side, and our right pointer is equal to the last element, which is basically the length minus 1. So we're going to start at the very left and start at the very right. And then basically, hey, while the left is still on the left side of the right, left is smaller than right, that means it's on the left side of the right, we're going to run this algorithm and keep looking. So hey, if the left side is equal to the right side, or say if the left side is not equal to the right side, big error, right? We're going to return false. But if it is, we can keep moving, and by moving, we're just going to move left to the right to the left, and keep doing that until they eventually connect. And if they do connect, then we're going to break it right here. This is going to break, say, hey, they connected and nothing happened, therefore they must be a valid palindrome. And that's when we will return true. That took too long. Check it out. Okay, thank you, and we're going to do a stack. Valid parentheses. I am not even going to do Figma anymore on these ones. I'll probably pull Figma for the harder ones, even though these are giving me more trouble than they should. So I already have something written. See, it's funny that I already have something written, but I don't recall, or this is mine, right? Yeah. But I literally had to make this account yesterday. Okay. I don't know what I wrote there. I don't need to. Oh, I love this problem. Okay, stacks are so fun. So cool. I love this. Okay. Basically, as you can read here, this will tell you what a valid parentheses means. So every open brace has to be closed, basically before. Let's see. So this open brace has to be closed before this square brace closes. So it has to follow the order of the inside must close before the outside. You cannot have something like this. This is inconceivable. This doesn't work. It does not follow valid parentheses. So we're gonna make a stack. In this instance, our stack is just going to be an array, and yeah, because Python, it makes this stuff pretty easy. So we're going to start off with an empty stack, and we're going to go ahead and then just start moving on through. So we're going to do a for each item. So we're going to do for element in string. We're giving a string of characters. We're going to check it. So I'm going to say if element is, I'm going to say if element is inside this kind of grouping. So if it's something open, we're going to go ahead and add it. Basically, if it's an open thing, if it's open, we're pushing in to our stack. Okay, we're pushing it in. If it closes, that's when we need to check it. So how this is going to work is you'll have, like, let's say you have this. Okay, so this is not valid. This is invalid because of this right here. This closes before this gets to close, which causes a problem. So how this will work is you'll have the stack. So you'll put this brace here, right, in the stack. So the stack looks at the open and it puts it in. Then it looks at the open parentheses, puts it in. Then it sees the closed parentheses, it's going to put it in, or more realistically, it's going to actually look at the top, say, hey, okay, there's an open parentheses here, therefore we can cancel this out. Perfect. You can see this open parentheses, it's going to put it in, or open brace, sorry, curly, it's going to put it in. Then it's going to see the closed curly, and it's going to say, hey, what's at the top? Oh, at the top is the open curly. We can get rid of it. Cool. It's going to see that open parentheses, it's going to add it in. Perfect. Now it's going to see a open square bracket. We're going to add it in. Perfect. But then it sees a closed parentheses. We're going to take a look. Is the closed parentheses is at the top at the top of the stack a open parentheses? It is not. That is an error. So when it puts it in here, it creates an error. So that is how the stack checks it. So hey, if this element is a open one, we could just push it to the stack. So basically stack.append element. Right, you can do append in Python, huh? Python append. Yes, you can. Beautiful. So hey, if it's open, we're gonna append it. Else if it is element is equal to, let's say, a closed open, oh, okay, so we're gonna say, hey, it's equal to closed open, and if that means we need to close out or we need to finish out our square braces. So we should be at the top of the stack. It should have a open square. Man, I hate saying all these things: square, curly, parentheses. I should be twisting it up. You can probably hear it in the speech right now as I keep messing up my words. Apologies. So if element, nope, not element. If stack, if the last element in the stack is equal to a open, then we're good. We're chilling. But if it's not, we're not good. We're not chilling. So if it's not equal to this, that's bad. That is not valid. We're gonna return false. And we're gonna caps lock it too. So if it's not, we're gonna return false. But if it is a open rate, then we're good. We can instead just pop the stack. And in Python, you can pop the stack by just saying, hey, stack equals everything but the last, which is what this does. This basically grabs everything but the last one. little Python syntax. Else if the element is equal to a close parentheses, then we can just actually, let me just copy my whole flow here. Yurt. Okay. Close parentheses. Open parentheses. Close curly. Open curly. Okay, so this will go through and basically check for valid closing and opening, but there's still the off chance that you can get something like, let's say the string look like that. This will not fail through this, because never once am I checking for an end curly braces, but this is not correct. So my current solution will not account for that, so I need to check it. So what will happen is at the very end, the stack will still have a open brace in there when it shouldn't be there. So at the very end, the stack should be empty if it's valid. If the stack is not empty, it's not valid. So basically, you can just say, hey, if length of you can just say return length of stack is equal to 0. So if the length of the stack is equal to 0, that's true, which means the stack is completely popped, which means we're good. If it's not, that's false, therefore it's not valid. Let's run it, let's see if that works. Invalid syntax. Okay, so I'm not surprised about that. This was kind of a shot in the dark. Yeah, that makes sense. I think I could totally do this. Oh, hold on. I don't know who it is. Do I? I'm thinking too caveman-like. Yeah. Okay, that worked. Got an error. Out of range. Oh, yeah, that makes sense. I gotta make sure. Okay, so here's what I'm gonna have to do here. I'm gonna have to do this. Else. If stack, sorry, length of stack is is equal to 0, return false. Basically what's happening is it starts off with a end brace and there's nothing inside the stack, so it's like, what am I even looking at? There is no -1, there is no end of the stack, and then it just kind of crumbles and falls apart. So my solution is slow. But, yep. Hey. And that's that. I can go ahead real quick, go over it again. So what's going to happen is it's going to grab every single element that's inside the list. So, hey, if this current element that we're looking at right now is a open parentheses, curly braces, square brackets, then let's actually append that to our stack, because we're going to want to use that for later. But if it's not, and the stack is 0, meaning, hey, we're looking at an end braces, but the stack doesn't have anything in it, then where is this end brace going? It's not colliding with anything. It's literally just by itself, right? Something like that. That's like this, right? This is not valid. What is this end brace looking at? What are we closing? No, that's not gonna work. So if this happens, it's false. Okay, but hey, let's say it's some sort of closed, but the stack is actually filled up with a bunch of items. So we're good. We don't have to worry about seg faulting. If the element we are currently looking at is a closed bracket, square bracket, but at the top of the stack a bracket doesn't exist, well, that means it's not valid. That would be something like, that. That's not valid. So if I look at this top one at this closed square bracket, at the very top of the stack would be this open parentheses. That's not going to work. It's not valid. So in this instance, it would fail. And the same logic works for the parentheses and the curly braces. It's just syntactual, hitting every single version. So when that happens, you just kind of return false. But hey, if it isn't the case, if we're actually good, we don't have to worry, then we're just going to de-increment the stack. We're going to pop the last item off the stack because we cancel it out, right? So if you think about it like this way, if you have this, we see this square brackets inside, pop that out. We see this right here, pop that out. Now it's clear. And then if you finish up going through everything and you don't ever, quit out early, looking good, looking fine, looking snazzy, then you can do one last check and say, hey, if the stack is empty, then we're good, we're finished, that's it. We popped everything, we cleaned everything. That means there's no problems. But if the stack is not empty, then that means there was some leftover items that never had their closing tag. So an open tag without a closing tag is a problem. This is something that, if you've ever worked with like HTML tags before, then this would make some sense, right? Every opening tag needs a closing tag. Same thing here. Okay. So that was 3, right? 1, 2, 3. I'm thinking for tomorrow, I'm wondering if I should just hop on the mediums, just start like going into these mediums, which is gonna get kind of a little difficult. I'm kind of like I would kind of kick my butt, mainly because I wasn't paying attention to arrays and hashing. But even still, I shouldn't need this to kind of give the problem away. I should be able to figure that out on my own. But yeah, these ones I will actually probably get my butt kicked a little bit. So the easy ones I was able to finish. Mediums might be a bit tricky. Thinking want to complete these 3 first, and then move on to this beautiful mess. How many got? Maybe I won't like complete these 3, but like maybe I'll do I'll do group anagrams. I'll do maybe like 1 of each. No, I feel like it's gonna be like so painful. Either 2 of them, or do like 1 of them and then I'll do like an easy. The number of easies are getting like dwindled down though. A lot of easy trees though. Sheesh. No easy tries. I don't think it'll work with tries though. Okay. I am wasting time now. Okay. Thank you very much. Thank you very much. I appreciate you watching all the way to the very end. And I will see you tomorrow.